Welcome to Deploy on Friday. Actually, this talk was handed in by Lars Rosenquist, and apparently the guy on the picture doesn't look like the guy that's standing right here. So my name is Jürgen Hoffmann, but Lars, he got sick on the last minute. I'm going to do this talk for him. So Lars, he works at Pivotal as a senior platform architect. He has 20 years of experience in software development. He started on the mainframe, fixing the Millennium bug back in the days, mainly with COBOL back then, a little bit of C and C++, and then he went over to Objective-C, and nowadays he's mostly working with Java and Spring and Java Enterprise. Lars is a very special character who is a big fan of agile software development and DevSecOps, and he's a great believer in giving power back to the teams instead of the old command and control structure. If you want to reach out to Lars, please do so. He's very, very active on social media and Twitter. You can reach him over LinkedIn as well. And yeah, he doesn't favor email too much, so use the social media one. So who am I? My name is Jürgen Hoffmann. Yeah, like Jürgen Höller, guys using Spring should know how to pronounce the first name. Sometimes in the States you get awkward side effects with that name. But yeah, I'm the manager of Lars. I also have 20 years of experience in IT. I come from a Linux system administration background. I was working as a local ISP, providing all the services that you need in the internet, like domain name systems, mail services, web services, and things like that. And later on, I also used Java and Spring mainly for integration services there. I'm also active in scripting and things like that. You can also reach me on Twitter or on LinkedIn. So what's this talk all about, right? It's to kind of work a little bit on the question to deploy or not deploy on a Friday. And we had some pre-talk conversations here in the audience already, right? So there are some people out there that don't like to deploy on Friday, or they give out a recommendation not to deploy on Friday. But why is that, right? This is what we're trying to kind of clarify here. And maybe a little talk in the conference. How many of you have an internal guideline not to deploy on a Friday? Can you maybe quickly get a show of hands? So a lot of people, right? All right. Another thing that we're trying to get down to is give you some practical tips on how to deploy with confidence, right? How can you get there? And then we're going to talk about, a real application dumpster fire. That was during his previous tenure of Lars. He was working at a large Dutch telco company, which resulted in, massive revenue loss, had a cascading failure, and basically led to a complete outage of a sales channel for a telco. We're going to talk about what they learned from it, how they turned it around as well, to make this a better experience for everybody, right? And to kind of prove to the business that the developers need some more power in kind of how to run and operate software. So to deploy or not to deploy on Friday, that's the question. And if you look at social media, there's a very popular hashtag at this time. It's called nodeployfriday, right? And if you look around there, you can find tweets like this. Don't do it, right? Do not deploy on Friday, right? It's read-only Friday, no change, no pain. Or you would see, this was tweeted on a Friday, obviously, do not deploy today. Geniet van je weekend, which is Dutch, stands for enjoy your weekend. And the t-shirt says, should I deploy on a Friday at 5 p.m.? No. What if I just need to, no, my God, don't. Just do it, right? And we were talking about this, right? There are dependent systems here. And then there's this tweet, right? The deploy button on a Friday night, right? It's like you secure it, put danger on it, put all these signs here, right? It says, do not touch. Not only will this kill you, but it will hurt the whole time you are dying. So really don't do this. So, but if you take a step back and if you look at the deeper message of all of these tweets, right? What they're saying is that deploying software results in a massive pain, right? And every change that you do in software development seems to be painful. So if you don't change, there's no pain, right? And if you don't deploy, there's no pain. And then, what we don't like about the statement is that it's an absolute statement, meaning that 0% of your software is suitable for deployment on a Friday 100% of the time, right? Is that really true for all of your software? Do you really think that's true, that you can never deploy software on a Friday? So, some observations from the history, right? So, people are seemingly afraid of the fallout of deploying their own work. Probably, they might have very good reasons, right? There are reasons why things are failing. But why aren't we taking steps to address those reasons, right? If there is something that is failing and we can observe why stuff is failing, we can then test for it and deploy it, right? And usually it's because it's viewed as extremely hard or even impossible. And during the conversations here before the talk, you would have, in an enterprise, an application is not simply a little piece of software that you deploy and you control yourself, right? You have interdependent services that depend on each other. You have cascading failures. So if one thing fails, other things fail. And if the other things fail, then the overall application fails, right? And this is why people are only in control of very small space and a very small part of the entire application. And so to change everything, that's really hard or even impossible. We're going to talk about later what kind of things can lead to a chance to kind of change this. So people stop deploying on a Friday, right? Because it takes time, right? And then all of a sudden, because it takes more time to fix things, you start deploying on a Thursday as well, right? What does that lead to? And let's be honest, not deploying is the easiest way to de-risk of something going wrong over the weekend. And again, or not again, nobody of us wants to be in a conference call with 50 people across 3 continents on a Sunday morning at 3 a.m., right? And you have this because if things go wrong, they really go wrong, you have a Severity 1 outage, customers are affected, things need to be fixed, right? And you have these 50 people on a conference call, and then all of a sudden, all you have to do is fix a one-liner because just some small change didn't really make it into production. So, what are some problems with not deploying on a Friday? So, what's the difference between a Friday and a Monday, really, right? Is it just the weekend? Or is it just because Tuesday is the next business day, and then you can fix something then? For your customers that are users of the software, there's actually no difference whatsoever, right? Services need to be available all of the time, no matter if it's a Friday or a Monday. And ignoring those problems doesn't really make them go away, right? Not deploying on Friday is not solving the problem. All of a sudden, as I said, right, you stop deploying on Thursday because remediation and mitigation takes more time and more time. And things will then get worse and worse. And so you end up maybe, right, with a patch Tuesday of the month, right, all of a sudden, if you stop deploying, if things get worse and worse. You create a workaround, things. So even if you don't deploy your part of the application, I was talking about the enterprise application, right, that spans a lot wider than the part that you actually control, right? Other parts of this application may deploy on a Friday. So even if the guideline is given out that you should not deploy on Friday, maybe someone does, and then things break anyway. And then you might find yourself in that 50 people conference call, even though you didn't do anything wrong. Has anybody experienced this? Some people did. All right. So you still need to apply patterns to protect yourself and the stuff that you control from your environment that you're depending on. Does that make sense? Okay. Or, again, right, you get that call on Sunday morning at 3 a.m. So how do we get out of this mess? Well, we could simply stop deploying overall, right? Let's just make this like in the good old days. Every 6 months, let's get together, we deploy then. we tell our customers our applications are working for a week or so, right? But we assure you afterwards it's going to be all better. No, this is not what we do, right? So how about we fix some things first and then we deploy, right? So how could we get to these first things on how to deploy, right? How do we find something? We could start by asking ourselves why, right? If you take a step back and analyze the situation that you're in, what happens during deployment, what fails during deployment, ask yourself these questions. Why are we afraid of our own software? Why are we afraid to deploy it on a Friday? Why can't we know if all is well or not immediately after a deploy? What hinders us to kind of see if the whole application is up and running, right? Not only our small part, but the entire application. Why can't we roll back or forward quickly? What is hindering us? Is it the infrastructure? Is it our deployment process? What is the reason for getting there? Why can't we handle outages or changes from our dependencies? So if someone else changes something in the enterprise application, why can't we kind of check this and make sure this doesn't happen? And why do we even need 50 people in a conference call on a Sunday morning to fix something in an application? Probably only a one-liner, as I said, right? Somewhere. Why do we need 50 people? Why can't we have a product team designing this? So possible causes. Applications have sometimes grown so large that you have no idea what your software is doing in production, if it's really working or not, right? You just look at your small piece and you say, I'm working fine. And when every team does that and everybody says, we're working fine, we hope that everything is going okay. But we need more insight into the application to understand if it's really working, right? We have no monitoring, APM, we have no observability of what's going on. The software that we deploy is usually too large. And we're going to talk a little bit about this, what I mean with that later in the example. The software that we're deploying does too many things. We try to package a lot of the things together in one deployment unit because back in the days, you know, when we just threw software over the fence and we didn't have this whole automation, right? Our IT operations department was annoyed when we brought over deployment units, right? Please deploy this for me, deploy this for me, deploy this for me. So the less we asked them to deploy for us, the better it was, right? Nowadays, you know, if you break down a complex system into simple components, it's much easier to manage and maintain this. And with the automation that we have today, we can break systems down into smaller components, right? Because we control how we deploy them. Okay? Since the software is too large, it increases the cognitive load on developers. You might have too many tests that take too long, or because the software is complex and very, very large, you might have too little tests, right? Because if you change something in the application, tests break, and then you simply run a skip tests on your build, and then tests are not run. Or you turn off specific tests, and you forget to turn them back on. And so things like this also lead to problems. And we have too many dependencies inside of the entire enterprise application. And this is not only true for software, but also for traditional organizational setup, okay? So the traditional organizational setup is to break everything down in their different departments with their different concerns, right? And what this increased was the feedback loops and the kind of communication cycles to get things going and to resolve issues, okay? And the deployment pipeline and process is simply too long. Good. So with all of these causes, this is why simply ideas take a very, very long time to go from idea to production. So how can we change? And this is just a setup and introduction, right? We have to admit that change is very, very hard. And sometimes it takes a compelling event, like I'm going to talk about later. But sometimes you don't even know where to start. So basically, if you start one thing in a very complex system, since it's very complex, if you change one thing, it's interconnected to so many other systems, and so many errors might occur that you kind of step back and say, if I change this, it might result into a lot of issues somewhere. So it's hard to see the light at the end of the tunnel. This is what we mean, right? So if you change one thing here, another component breaks, you do another change, another component breaks, and you get there and you say, I don't know when this will stop, right? Sometimes when the application is larger and it spans over several units inside the organization, you can't even see the tunnel. So without even knowing where to start with the change, right? Because everything is so large, and you're saying that it has always been like this. We always needed to package this like this. And this is, how we do this in here for years and years to come. So the easiest way is to kind of focus on the domain that you control, the small application space that you control, right? And admit that, change is, as I said, hard, and it's a marathon. It's going to take a long time, right? Although you all work mostly in agile sprints, I believe, but a marathon takes a lot longer. And you cannot expect to kind of go to the start line today and expect that you finish the marathon right away, right? So it takes practice and it takes time. That's what I'm trying to say, right? So if you want to start deploying on a Friday, you have to start small, start with the stuff that you control, and get better over time. But every marathon, no matter how long it takes, 42 kilometers, starts with a single step. So you should start. And as I said, even if you can't even see the tunnel, right, challenge the status quo. Just because you have done something for years and years, it might not be the best approach, right? It's just the stuff that everybody is used to. These are two different things. But accept that you cannot change the whole world in one go. So the suggested approach from this application dumpster fire to this deployment heaven, where everything is automated and everything is small and microservices, right? And still you don't deploy on a Friday. So it's not that easy, right? So even though you break down components and everything, it's not that easy to get from an application dumpster fire to deployment heaven. So this doesn't work apparently in one go. But what we can do is, take a first step. And this first step is not maybe the ideal scenario. So what I'm going to talk about in this example, I'm going to show you the first step that Lars has taken. But this dot is still red, and this is still red for a reason, right? You should start somewhere, control the stuff that you can control, improve the situation, improve the deployment of the stuff, and then once you prove that, you create a current, right, that you can initiate a second step and a second step, and then after many steps, these are only 5, there will be many, many more, trust me. You will get to deployment heaven. But this will take time. So what we're trying to say with Deployment Friday is that not all of your software, but some of your software is suitable for deployment on Friday some of the time. This is a relative statement. It gives the control back to you when you think you should deploy, right? And you know what works and what doesn't. And for the stuff that doesn't work, you know why it doesn't work, and you have a plan to mitigate this. Okay? So it's not an absolute statement, as I said. It says deploy if you can, don't if it's not safe. But this basically doesn't apply only on a Friday. It should apply to every day of the week. So enough of the setup, enough of the introduction. Let's talk real-life, massive, cascading failure. And this is an example of Lars. He was working at a telco in his previous life before Pivotal, and he was working on a team that was handling the online web shop. And they were selling mobile plans there. You could buy mobile phones there. You could select your mobile plan, the hardware that you wanted, right? And both acquisition and renewals of subscriptions is what you could get on this web shop. So how did this web shop application look like that he was working on? There was a storefront. There was a web content management system. This web content management system was responsible for the design. All of the design was rendered on the server side, right? It would just present HTML back to the user. There was an integrated order management, a product management, which usually shouldn't belong into an online web shop because products in a telco are usually managed somewhere outside of an online web shop. But I'm going to explain later why they had this. A customer management solution to handle existing and new customers and enter new customers and various other bits. And all of these parts were then packaged through Jenkins and a lot of custom shell scripting into a single monolithic WAR file. This WAR file took 15 minutes to build, right? So it's a classical monolithic application. After this application has been built, they used Jenkins again to deploy this into the data centers. So they had 2 data centers with a cluster in each data center, 3 nodes in a cluster. It was running Linux. He used Ansible to deploy the virtual machines. All of this took 5 minutes or so. And they deployed a Tomcat on these servers, and they put the application in there in all of these data centers. And it took 15 minutes per node to start this application. Okay? So in total, if you take the build in there, it's over 1.5 hours, almost nearly to 2 hours to run a single deployment of this application of the web shop. Anybody else still has an application like this that he needs to maintain? There? All right. So you should know what Lars is talking about, right? So it takes a long time when you're like, do I do that? I don't know. So what were the problems with this application? It was one application to do everything related to the mobile online web shopping experience, right? Both acquisitions and renewals for mobile service plans and things like that. Product management, storefront, customer management, order management, web content management, and a few more. Every change in the UI, every template change needed to kind of redeploy the entire app. So every little change resulted in 2 hours of deployment. Took 50 minutes or more to build, 50 minutes or more to start. The rendering engine, because they wanted to present only HTML, was caching the rendered pages, right? Now, when they acquired this web content management system, what they didn't know, or what they didn't think of, was that small content changes invalidated the entire cache. And then you hire 3 or 4 content curators or content managers that change the content because you need to change content so stuff stays interesting to people. And they make a lot of small changes, right? You pay them. You pay them to make these changes, and they do this throughout the day, basically leaving you with an invalidated cache all of the time, giving you full renders, almost all of the day. And for a full render, the database had to be hit every single request. Now, another problem that they had was they used a third-party e-commerce engine that they bought. They had no control over the internals. They just used it as a black box, right? So nothing that they could automatically test and check if it's working okay, because it was proprietary by nature. Using this component had a special license attached to it. So when this application started in Tomcat, it would check the environment and would ensure that licenses aren't violated, hindering them to scale horizontally or dynamically. I mean, horizontal scaling with 50 minutes of start time Isn't really horizontal scaling, but it would have at least solved some of the problems. And contract negotiations took them months to kind of realize. Another problem was with the application that everything that they did from these components that were in there, the customer management component and things like that, were done through synchronous online calls to backend systems. Okay? And the backend systems in a telco, they were there for a long time. They're pretty slow. They sometimes had low availability because things needed to be updated in the backend systems, right? If your application in the store isn't available, that's not a big thing, right, during nighttime. But in an online shop, that's a big thing, right? So basically, this always left them with a down application. And they also had poor data quality from these backend systems, meaning they had to kind of put in mitigations, like the product management thing, to kind of make sure that this data quality was good. So one example that Lars gave me was, if you would pull a customer record from one backend system, and you wouldn't alter the customer record, and you would use the same data to a second backend call, you would get this customer is not existing, right? So you would get a faulty response there. And so this was also a problem that they had. And backend services are backend services, and they're usually not scalable as well. So duplication of functionality, as I said, the product management functionality in an online web shop, right? If a bundle is wrong or has a wrong price attached to it, you can send out a memo to your customer service center or to your stores, right? Saying that this is a wrong information, don't use that, and people will adhere to it. This doesn't work well in an online web shop. So they had to kind of reproduce functionality in the online web shop to make sure that, if there has been an error, they can manually correct this. Okay, so this is something that they had to reproduce there. So does this sound bad? Well, things got a little bit worse. So if you look at the telco web shop, the load that hits the website usually stays pretty steady over time. So even if you bring out a new mobile service plan, or some usual vendors release a new phone, like Samsung, but there's one exception to this rule, right? And I hate to say it, but it's true. It's when the iPhone launches. So usually the iPhone launches here on a Thursday. Usually in the States, it's a morning event, which in Europe is an evening event. And so in Europe, everything starts, you guessed it, on a Friday. So they have one major launch per year. It's usually in September. Pre-sale starts on a Friday, and it increases the traffic that hits the web shop. These were their estimations, 20 to 50 times, right? There's a big hype around the iPhones. Nowadays, not so much anymore, I'd say, but if you think 5 years back, there was a big, big hype around iPhones. And as I said, in Europe, it's in the evening, so the next day, people come in, they want this phone, so they're going to go for it. So, and for a telco, if you sell these new premium phones and you have 20 to 50 times the traffic hitting your website, this means a lot of revenue for you, right? A lot of people want this new phone. There's a lot of dollars involved there, millions. But not if your site's not up. That's definitely a problem. And so another thing about iPhone or telco customers is usually they are very sticky, right? So you choose your mobile plan, you choose your data option, and then you usually stay with the telco provider for a long time. You look at the coverage, right? This is how you make a choice. But if you're an iPhone addict, right, and you want this iPhone, and you get similar contract options at other telco providers, and you can't get the iPhone from the telco provider that you love, you are likely to go to a different telco provider. So there's another issue with not being able to kind of serve your customers, right? You will lose future revenue as well. So not the people that, like the latest and greatest iPhone. So what happened? What was the failure? 9 a.m., Friday, iPhone was announced the day before. Everybody was happy. Yay, new iPhone. Boom, the web shop died. I mean, instantly. So 9 a.m., nothing works anymore. Several services that the web shop depended on also died, right? Which was a cascading failure. So people started calling the customer service center. If you can't get the phone online, you ask what's going on. You call the customer service center. Hey, guys, I'm trying to order the new iPhone. Nothing is working. What can I do? They're like, who are you? And you're like, well, my name is Jürgen Hoffmann. They put this into their system, and they're like, yeah, I'm sorry. We can't help you because our CSC app is down as well. Then you're like, what's going on with you? Are you not working anymore? So all grumbling to myself, you go out steaming to the physical store, right? You go there, hey, I'm Jürgen Hoffmann. I want the new iPhone. I saw this yesterday. This is a great thing. Yeah, all right. Nice that you're here. Can you please come back tomorrow because our systems don't work? So this is a real problem, right? So no sales for the iPhone. This is what happened. Or any other phone, or any other subscriptions were possible for several hours during that time. So it was a real cascading problem and a real massive revenue loss for this telco. By the way, I posted a link of Lars' LinkedIn profile. He asked me not to mention the telco, but hey, what's LinkedIn for, right? So, so it's a massive revenue loss. So what really happened? Root cause analysis. There's a chain of events that happened. The new iPhone was only made available for new or for existing customers. I'm sorry. So that required people to log into the web shop. So if you hit the web shop, you wanted the people to log in, which resulted into a hit against the customer master service. So for each login, a request had to be made to the customer master service, who retrieved the customer record from the backend system and handed this over to the online web shop. Now, since there was 20 times increase of the load, this backend service couldn't handle the load anymore, and it didn't scale automatically. Even worse, this backend service just went unresponsive in terms of it didn't respond anymore. So it didn't fail, which monitoring systems would have kind of recovered. So in the monitoring perspective, everything was fine, everything was up and running. It was just not responsive. And of course, the customer master service was also used by the customer service application, and it was used in the physical stores to kind of find out, if the person that is entering the store is actually a customer. So everything basically went down. So, and of course, when you have a new iPhone coming up, you have content curators, you pay them to make changes at 8:59. So basically everything started from cold caches, which also resulted into a database hit for every request that came in, and everything failed. So how do you feel about deploying changes in this environment? Nothing is working anymore. You have current load of 20 times the normal load. It's I would say impossible. And we were seeing this before, right? So challenge the status quo. We can't do anything. It's impossible to change something. So as you can guess, for Lars, this was not a very, very happy Friday, right? They had to mitigate this over several hours, and after several hours, they got the service back up, and they started slowly selling iPhones. So then the aftermath begins, right? So people want to know what went wrong. So his team got the attention of the CIO and the VP of App Dev, because apparently this wasn't the first time the iPhone launch caused a failure. So would you say this is a good or a bad thing that the CEO and the VP of App Dev had this attention on your team, putting a lot of pressure on you? Both, yeah. It's not good to have that, but it's also a great opportunity, right, that you can use. right? So what this CIO wanted, right? The board of directors was involved, telling the CIO that obviously he doesn't have the infrastructure under control, right? Because it was the second time it was failing. And they kind of put him to a test and saying, you need to fix this. This must not happen again, right? And Lars' team was convinced that they could change this, right? But the status quo and where they are in, the systems that they were using was kind of making this very, very hard to achieve, right? So they asked for a mandate to make sure that this never happens again. And this is what they got from the CIO. And they asked for a carte blanche, so they could challenge the status quo, right? So they could go in and they could, if they are dependent services or dependent teams, that they could influence those teams to change things, to make sure that this doesn't ever happen again. Okay? And they decided, but they were, as I said, they were convinced that they can fix this. So they decided to go for a two-tiered approach. One was to stabilize the current application, which was handling, renewals and acquisitions of new subscriptions, but also specifically for the iPhone launch, for the next iPhone launch, because this was the only thing that the board of directors really cared about, re-architect the application for the next iPhone launch. Just make sure that this never happens again. All right? Talking about a first step. So what did they do to stabilize the current application? They didn't do a lot, right? So since they analyzed that the customer master service failed and it just went unresponsive, they decided to kind of implement circuit breakers for the critical endpoint calls, right? To kind of protect themselves against the failing surroundings, making sure, if these surroundings fail, at least we know what's going on and we can tell quickly which of our surroundings is missing or is failing. And they also saw that, some connect and response timeouts were set to ridiculous values. So they made sure those are, meaningful as well. But this was pretty much it. Because from their perspective, the existing application, the monolith, was a dead end anyways, right? There's too many things that they didn't control. There were too many constraints, so they concentrated on the new architecture. Okay? So how did that look like? The new architecture was basically just, again, only for the iPhone launch, right? A landing page for the new iPhone where customers could come in, log in, get to a product detail page, and then go to a checkout page. All of this packaged in a separate deployment pipeline. It's just 3 static pages and rendering done on the client side because it's an Angular application. And the deployment of this took less, or building this took less than a minute. Another thing what they did was they created a microservice, order service, packaged this separately in their separate deployment pipeline, which also took less than a minute. And a customer service, which was a proxy service for the customer master service, just so they are under control and can make sure that everything is working correctly. And they used another mitigation step, which I'm going to go to later, to kind of make sure that they're independent of this customer master service. So this was basically their beginning to kind of build a separate microservice for the customer service so they can be independent of their customer master service, which also, was taking less than a minute to build. All of these as Spring Boot executable jars. They use Spring Data JPA for the data service and Spring Cloud for kind of making sure that they are safe. Then to deploy all of this, right? How long did that take? Only 5 seconds per node, right? It's basically just copying some files to a static Nginx folder, right? Instead of a complete application, just copy over some files. If you look at the microservices, it took less than 10 seconds per node. And the same is true for the customer service. Now, the benefit of breaking up this application into smaller components, this complex monolithic war into these small bits, resulted into the fact that they can also use this in parallel. Meaning, you would decouple the front-end developers from the back-end developers, right? If you had a small content change in the UI, you could deploy this independent from the back-end services. And not like in the past, everything needed to be packaged up in this big, huge monolithic war, okay? So what were the improvements that they saw? The build time went from 15 plus minutes down to less than a minute. The deployment time from 15 plus minutes per node to less than a minute for the complete 2 data centers. Decoupling of components, as I said, kind of helped them to make the development teams independent of each other, right? That you can deploy with more confidence. A small content change would only result in a redeployment of the front end, not of the back end, and you would know that everything is still working stable, right? It would build the confidence of the teams. You can parallelize deployment activities if you need to. You don't have to all the time, but you can. Frequent content changes have no impact on the rest of the system. Everything was static from a server perspective. There was no more rendering through the use of Angular. On the server side, everything was done on the client side. It's also something that they took. In this customer service, they decided to go a little bit further, right? They wanted to become independent of the customer master service. So even though during the next iPhone launch, even if that service fails again, they wanted to be operable. So they decided to take a database dump from the customer database and load that into an in-memory database that was managed by this customer data service, right? This dump was done every 2 weeks, and they limited this to eligible customers only, so only for existing customers you could log in, right? And they accepted the fact that this data might not be accurate, right? But this data was accurate enough, and they decided to go down this road to stay operable and to have a workaround, not a workaround, to handle things, when you have an error, right? So if you have a faulty customer data set, right, you give the option to correct the data. This would improve data quality, so the overall data quality that you have. In the end, in the past, you had poor data quality and you had no chance of fixing this. And now you have a faulty customer data set. You give the customer the opportunity to kind of fix the data if it's wrong, right? You improve the data quality, and you have a different path to kind of, if the customer didn't change the data and you still get an error, you have a separate handling mechanism, right? But for them, it was that 90% of the orders were correct. Only 10% of the orders might have errors, right? 10% of the data. And this is something that they would accept. So as I said, so in case you have an error or missing customer or you have faulty data, you would have an alternative flow on the order service. So what else did they do? They also kind of went on a change inside of the order service. So they went from synchronous transmission of orders to asynchronous submission of orders, which gave them the ability to easily correct faulty orders and resubmit them, right? Hand them over to the order system. In cases when they are dirty, you would have the customer service call the customer, right? Ask for more details, put this in, and then you could handle it then. They added APM, so monitoring, which helped them to monitor the knowns. But also, if you observe an application over time, you can build trend lines, right? They decided that they wanted to be alerted over the unknowns as well. So when trend lines are violated, you would get a notification as well. And breaking down the complex system into smaller components also made it easier to monitor. So instead of monitoring a whole web application archive with components inside that are hard to get into, once you broke down this into smaller components, it's much easier to monitor it because you know which component is failing and is not working. And since this application was only for the iPhone, the very active listener must have seen that they had a product management component in the web application that they didn't replicate in the new application architecture. But this was because it was only for the new iPhone, so they put an iPhone product detail JSON file somewhere on a web server that they just pulled down time and kind of took the data from there, knowing that they would need to improve or implement a separate product management service later on, right? But this is also an example of not trying to change everything in one go. Take, small steps, right, and keep it simple as possible. And various other little things. So what happened at the next launch, you might ask? It went smooth. There was no customer-facing issues. The site stayed up 100% of the time. They had some issues in the back end due to the lack of data quality, right? And customers didn't kind of provide the right data. But they were able to easily fix this directly in the DB through the customer service, or maybe have the customer service calling the customers and redeploy the application. And since the next iPhone launch was also on the Friday, and they still had some changes to do, they did multiple deploys on the Friday. But since they gained this confidence that you can decouple responsibilities from front-end developers to back-end developers, and you can deploy independently from each other with a lot of confidence, that made them deploy 25 times, several dozen times. They had multiple content and UI changes, and those changes were done in minutes, which was a big surprise because it was during the live hours, during the launch, and they were able to kind of see changes in the online application on the go, right? And this, to you developers, this might not be a big thing. But if you speak to salespeople or people from the business that are not used to this is like a big change for them, right? They're like, oh my God, I can change things in a matter of minutes. They go crazy. I mean, they go berserk. Work follows suit, right? This is not always in our interest, right? Just because we can deploy every 5 minutes doesn't mean we have to. But yeah, in their case, it was a big improvement to them, right? Made a big noise. They had no weekend fallout because they fixed every severity 1 stuff on a Friday, and believe it or not, the people went home early. And now imagine you're in an organization where 2 years in a row, the iPhone launch caused a big hiccup, right, into all of your systems. And this year, your people leave early from work. It's a big improvement, right? This makes some noise inside of a large organization, right? This is what I mean, right? You have to keep on doing it. Of course, not everything was 100% smooth. There was some small hiccups, right? And they were able to fix them on a Monday. So nothing that the customers kind of. So the lessons learned: observability is key, right? You need to know what your application is doing in production. You also want early warnings, right? So when I was talking about the trend lines and violating the trend lines, right? You want to get this early, not when the customer starts calling you. You want to be in control of when something is not working. You want to know that. When you reduce application complexity, right? And again, I'm not saying that this was always bad, but with the possibilities that we have today in breaking up components into smaller pieces, and we are in control of deploying these small components to our infrastructure, we should think about reducing more complexity here, right? It makes it easier to monitor each component. It also reduces the feedback loops, right? If we parallelize more, right? If we start decoupling front-end from back-end developers. And then, this gives all other possibilities, and it improves your reputation to sales and business folks as well, right? They see what's possible. You become the guy that kind of drives that for them, right? That change. They changed the CI/CD pipeline, as I said, from hours to minutes. They had, since some of these service components had only JSON interfaces, they were able to fully automatically test them. And even in cases they had failures in their REST services, you could then kind of do an analysis on what caused the failure, replicate that failure, test against this, and even improve confidence in your service and implementation over time, right? You can really go to fully automated testing. And what they did also something that isn't disclosed here because it's more a technical track. They broke down silos in their organization as well. This is what they use the carte blanche for, right? So they asked the CIO during this iPhone launch and for the re-architecture of the application, we want the people close by, right? We want people from security sitting by, we want people from IT sitting by, right? We want people from the business sitting close by, so we do not need to start any tickets, right, or send emails to the other teams waiting for them to kind of pick them up. We want this stuff resolved quickly, right? So put them all together in a huge office space, right? Having them all close together, reducing the feedback loop. So what else did they kind of learn? It's important to reduce your dependencies, to kind of mitigate cascading failures, right? The customer master service in their analysis was the main cause of failure. Making themselves independent of the single point of failure meant a lot to them, right? So check internally and externally what kind of dependencies you have. If possible, use caching to kind of, if you need external data, right? Do you always need an online call to a system, right? Or is there another possibility? Is eventual consistency something that you can live with? Increase robustness and resilience, right? So save yourself from the failure of your dependent systems, right? Implement circuit breakers where you can, so you know what's going on, right? And check the timeout settings. So if you use Resilience4j or other kind of libraries to help you implement circuit breaking, you get good defaults out of the box. But what they kind of discovered back in the days when they changed this was that if you use a library like HTTP client to do online calls to other systems, you would get ridiculous timeout settings. So maybe a minute, David, how long is the setting usually? 60 seconds? Is it indefinite? I don't know. Could be indefinite, right? Sometimes. Use blue-green deployments. This is something that they've already used before they changed the application, right? But keeping your application up and using deployment patterns like this can largely improve the way that you roll out applications and keep applications available. So, when we look back at our diagram of the application dumpster fire and deployment heaven, and you think about a large telco, right, with a core component to their business model, right? Did they get from the dumpster fire to deployment heaven? I don't think so, right? So there are still a lot of things that they need to be doing, right? If you think about the product management service, they were just pulling this in statically from a service, right? There's still other things that they needed to improve and get going, right? So basically, they went from the dumpster fire to a good first step, right? But they took what they had in control. They made sure that, whatever they were able to control, they would control, yeah? And they would improve. Stabilizing the current application, invest as much time as needed to stabilize it, and then focus on the new stuff, right? And when you focus on the new stuff, review how can I reduce complexities. Okay? So how could you start? Do you remember the why questions from the beginning, right? Start with that why. Review one more time. What is hindering you from deploying on Friday? What are the problems you are facing, right? Do I have complete observability of what my app is doing in production? Or am I just seeing if services are up, right? What do I rely on? Reduce the complexity, right? Now is the time to break these large monoliths up into smaller components, right? Doesn't mean that you need to do everything as a microservice, but you should know when to put something into a WAR file and what would be better in a smaller component. And eliminate or reduce your dependencies as much as you can, right? Protect yourself against your surroundings, protect the stuff that you don't control, with the stuff that you control, okay? There are more sessions here at SpringOne Platform that I want to recommend to you that go deeper into the topic, as this was only a high-level talk. There's How to Live in a Post-Spring Cloud Netflix World by Olga and Marcin. There is a Spinnaker talk, Cutting Edge Continuous Delivery, with Spinnaker from our colleague Andreas Evers, who is an SA in the Netherlands. And there is another talk, Building Robust and Resilient Apps Using Spring Boot and Resilience for J by David Caron. And there are many other talks that go deeper into this topic. If you want to learn more about the topic, I also recommend that you read Accelerate, which goes into DevOps and how to measure DevOps efficiency. SRE is a topic that I didn't go into in the talk, right? But something that I really recommend is site reliability engineering. And Hannah Foxwell, a dear colleague of us, has a great video on what reliability engineering means for humans. So I highly recommend this. And to understand what observability really means, going deeper into the topic of observability, I recommend this reading, which has a 3-year retrospective about, what it really means to achieve good observability. All right. That's all from me, all about the presentation. I'm happy to take questions now, if you have any. Yes, please.
So, you still had some failure left. It sounds like one of the exciting incidents was basically that the on server was overloaded and it's still preventing anybody from doing anything. Could you talk a little bit about in how many ways the process is still improved if the on server happened to fail again?
Yeah. So that's a good question. So the question was around authorization, right? So not only the customer master service was down, which returned the customer record, but also, this was only available for customers that were authorized in the system, and if that's a single point of failure. Yeah. So I would say that this is still a possibility, right? That things can fail, but you have to kind of secure yourself around that. If you implement a circuit breaker there, right, you can assume that it is a customer that is an existing customer, and you can decide, if that service is failing, do I want this customer to still place an order, right? And I let this follow up with my customer service team later on, right? I just ask for some questions. What's your customer name? What's your customer number, for example, right? You put this in, and then you could follow up with the customer service team later. But by implementing this pattern, you can handle different things differently. You know what I mean? Does that make sense? I'm sorry I can't give a better answer here. Yeah, but any other questions?
So you talked about observability and early warning. How do we achieve that?
How do you achieve that?
Observability and early warning. How do we go about it?
Yeah. So you choose a monitoring system that gives you the ability to kind of look at your system, how it's operating under normal conditions, right? So basically giving you trend lines, and how a normal day, normal operating hours look like, right? And then you could do that against different services that you have, yeah? So you know what they are doing. And then if your services or if your system starts behaving awkwardly, right, some of these trend lines are violated. And then if one service starts violating a trend line, maybe another service starts violating a trend line, and you make sure that, if this trend line is violated, and you can do this in various ways, right? If it's violated just, immediately, or if it's violated over a long time, or, if there are spurts or something that this is violated, you can get notifications on that. But this is the time when you want to look into your system, right? So you don't want to look into your system when it's working under normal hours. This is when you don't do the analysis. Does it answer your question?
So is there something that Spring or Pivotal provides? If I'm running microservices on ECF, for me to go about this early warning, is there some setup that I can do? Are there some products available that work well with Pivotal?
So the question was, is there anything from Spring Boot or Spring Microservices that automates or helps the developer in doing this, right? Yeah. David, do you know something? She has a microphone. You want to say this one more time through the microphone? Okay. That will be good. Can you repeat the answer one more time?
All right. So in different ways, observability is facilitated within Spring Boot apps. So that's the actuator that emits metrics that can be sent in a very easy way to either something like Prometheus and Grafana, which is external to your system, but also if you're running on Cloud Foundry, there is a component called PCF metrics that gives you, on one hand, all the logging aggregated and searchable, and on the other hand, live graphics coming out of your metrics endpoints from the Spring Boot actuators.
Okay. Does that answer the question? Okay, perfect.
Any pointers on, you talked a lot on deployment Friday. If there is a system which needs to be always 24/7, you cannot deploy it. It's very difficult to find a window of deployment. Any pointers from that perspective?
Okay, did I understand the question correctly? It's tough to find a window of deployment? Yeah. So there are different deployment patterns, right, that help you deploy an application while the old version of the application is up. There are blue-green deployments, right, or canary deployments. Different patterns that you can utilize to kind of deploy even though your application is running. I don't have a link available, but I can obviously point you to the right resources. It's not a problem. Just send me an email. By the way, this is a QR code, which I didn't mention yet, leads to a feedback form, a retro board. If you want to give some feedback, the password is keep it simple. And Lars will be happy to answer, even more questions. Any other questions? Go ahead. Yes?
Would it make sense to position you again either way, adding like some big service there that's got a lot of file things in place, having each team like their own little one that's just one of these.
I'm not sure I understood the question correctly. So there's a backend service. A lot of different teams use this backend service. Does it make sense to kind of put something in front of this backend service?
One single app for all the teams to use, who's blocking from that, or each team to have like their own. It's either one single point of failure
Yeah.
or a lot of repetition.
That's a good question, right? It's tough to answer here on stage, but I think it highly depends on what you're trying to achieve and the use case that you have. David seems like he wants to say something. Okay.
We didn't talk a lot about it, but we've recently started adopting blue-green deployments. And one of the issues that we noticed is that without the automatic canary analysis, it's very manual. I know that Pivotal is using Spinnaker, I believe. Are you aware of any other products that can use a Spring Boot and say AWS for automatic canary analysis?
For automatic canary analysis, another product to do blue-green deployments.
Because I don't believe I can use it with AWS code pipeline. I don't think I can use Spinnaker yet.
Well, I don't know any competing product, but it would be great if I could take the question with me and come back to you via email. Is that possible? Yeah. I'll reach out to our product teams with that question. Okay. Yeah, but it's about, it's not about Spinnaker. So I would have to ask. Okay. By the way, the question was if there are any alternate or different products than Spinnaker to do blue-green deployment analysis or canary analysis on blue-green deployment. Yeah, with Spring Boot. All right. Okay, go ahead.
The example you gave here is, in a lot of ways, very, very interesting and unique. I think most of us are not in a situation where we encounter catastrophic failure where we got buy-in from the VP level all the way down to say, okay, go ahead and re-architect your problems the right way, build it from the ground up with monitoring and Spring and all these things from day zero. I think many of us are kind of stuck in the middle and say, okay, well, we don't have buy-in to go re-architect, we have some of the buy-in to go fix some of the problems, and so I was just kind of wondering, if you're taking more of an iterative approach to that here, what would be your advice kind of starting?
Yeah, so I wouldn't go as far as saying, they got the buy-in to re-architect everything. So the carte blanche that they got was to kind of just make sure that during the next iPhone launch, this doesn't happen again, right? So everything else needed to stay the same. This is why they stabilized the current application. But since they provided the success during the iPhone launch, this gave them much more meaning in future conversations with those people responsible for the application architecture, right? So it gave them a huge buy-in with the VP of app dev, right? They needed to prove the point that they're able to kind of make sure that this doesn't happen again. And now that they made sure that this doesn't happen again, they get more buy-in. And then you can take the next step, right? And then you can take the next step. This is, what I can say. And nobody wants this buy-in as well, right? So this catastrophic event. Okay, there's only 1 minute left before we can go to lunch. Maybe a last question if there's one? If not, thank you guys very much. Enjoy Spring One.